Hey guys, let's go ahead and get started with Microsoft Excel. We go to Excel and here is our data. We have three columns which are occupied by this data. Column A has the numbers coming for treatment A, and then we have the numbers for B and we have the numbers for C. If you look into the Excel, in the Excel the data is in the rows and in the columns. So rows are numbered here 1 through whatever, and columns are labeled A, B, C, D, E, F, and so on. This kind of formation where the data is in columns, it looks wider to us, so that's why we call it as wide format. A, B, C may be three different treatments, or these may be the levels of the same treatment. Sometimes the treatments have multiple levels. For example, gender, that's the treatment, and that might have male and female. So these are the levels of the treatment, same treatment, gender. So here we have, suppose these are three treatments, A, B, and C. Within those cells, beneath each treatment are the responses, right? So suppose we have how many? This is the first row, that is the labels, and the data goes up till row 13. So we have 13 minus 1, 12 entries for A. So these are the 12 individuals that responded to this treatment A. They may be anything. In technical terms, we call them as experimental units. So the experimental units that are getting the same treatment, they are replicates with respect to each other. So these are the replicates for A, these are the replicates for B, and so on. This kind of formation, as I said, is the wider format. We also have the long format. In the long format, you have these treatments all in one column. So we have A's here, then beneath A's we have B's and C's, and the response is all in one column. So it looks more longer than wide, so that's why it's called as long format. So sometimes we might see these replicates here too. So we can say replicates or reps. And how many replicates are here for A? We have 12 of them. So we can scroll down till where A finishes, and we can go here and do fill series. We can copy this and paste it down for B, and we can do that for so we can do copy, Control C, and scroll down to here, Control V, and same I can do for the third treatment. So it depends upon the softwares. Some of the softwares they prefer the data to be in this longer format, and some prefer in the wider format. Let's see how Excel toolkit needs our data. So before we proceed for the data analysis in Excel toolkit, let's go and do some fun with the individual Excel functions. Functions are here in this menu, this drop down. So you can go here where this sign of summation is there. So the first function which is showing us is sum. We can apply a function, for example, here in this cell, and whenever you go and click this, it will automatically fill it up for you, and you can check then whether the data which is selected in this in this selection region is the same what you want, or if it is not the same, you might gonna go and change it. So this sum function is summing from the numbers which are present in the cells. These cells are at the intersection of the column label as well as the row number. So for example, our data ranges from E2 to E13. That's what we want. There is another way we can apply the function, is we can write it ourselves. So what I would prefer is I go like this. So we can put an equal to sign here, and then we want to sum them up, so we can then press S and then U, and here is our function sum. and then we can go and select the first cell and keep pressing the left click and start moving down with the right click till you reach to your destination. So that is E2 to E13. You can also write it yourself, so you can do you can write it by yourself, E2 to E13 here. So that serves the purpose. So this is the sum of these numbers, and for these functions you can drag them and they may be applied to the next column, whatever the case may be. So if you want to apply to the next column the sum for the so we can go here when this is mouse. So this white cross is showing us the mouse and its location. So when we come to this cell, this formula, and cross thing, so we can then drag and the function is applied to the next column. So now it is 2F2 to F30 next, which we need goes to G2 to G13. Alright, so we had the sum for these numbers, so let me write it what we are doing. We want the count of these numbers. That may be interesting. Here we know these 12 numbers, but sometimes you have a data set down there and you don't know how many values are there. So this function count, we have their means, right, and what we need, we might be interested in median. Sometimes cells are also interested, so maybe we are interested in quartiles. So quartile 1, quartiles are, we split the data into 4 equal parts. There is first quartile, and that is the number to the 1/4 of this distribution or this sample. We sort the numbers and take the lower 25% of the numbers, so lower 1/4 of the numbers, and then we have the middle right half of those numbers, which we call it as Q2 or quartile 2, and that is the median, midpoint, same as median, so that's quartile 2. And sometimes we are interested in the third quartile, the 3/4 of the numbers, so that may be interesting. We might be interested in the variance of these numbers, another parameter, or statistic if it's a sample, and we are also interested in standard deviation and sometimes standard errors. How many numbers are here? We can also check those replicates or sample size. So each treatment has different experimental units. Here they are equal, so this is, we can plug in that one as well, and sample size, and these are your replicates, the first individual and then up till how many we have. We can go and do fill series. So total we have 12 numbers. Right, so we go here and there we can apply a function, as the name indicates, count. So there should be some function like count, so we can go count, and then we can write our we can select our range of numbers. So it goes from here to here, so count of these numbers, so it's 12. Same way we can apply the function towards right. Okay, for the mean you can apply a function average, or you can take the sum and divided it by the count. So first we do it with this sum divided by count. Sum is there in E14, so you can directly bring the value by calling that cell divided by E15, so that is the mean for this distribution, and then we get the mean for the other, and we get the mean for the third one. Or you can also apply the function which was there, it was average. So we do average, and we can just write it E2 to E12. So average of these numbers, same as which we calculated before. Sorry, E2 to E13. I was wondering why these numbers are not equal. Same way, we want to get the mod. Mod is the most frequently occurring numbers, and in the curve it determines the height of the curve. When we plot these numbers as a distribution, so we will get a curve. So mod is the thing that will determine the height of this curve. So we can go like mod. Within mod we have mult, mod dot single, and just mod. If this symbol is there on those functions, so that means that was the old function used in the. This function is available for Excel 2007 and earlier, so that was, but still it applies with the latest version. So let's go with mod.mult because it returns the most frequently occurring values, and if you have more than one values, so it will give you all of those values. So mod for E2 to E13, that's where our data is. So it's 9, here it's 20, and here it's 41. Median, as the name indicates, gives us the middlemost value. You take all those numbers and sort them. So once you sort them, and you can go and pick up the middle number. If it is the total numbers are even numbers, you will pick the middle two and take their average, and if it is the odd numbers, so obviously the median will be exactly in the middle. Quartile 1, the function is we are writing the functions with their name. This is called as function call. So we can go with quartile, and I can go with the older previous one. So we can take the array, these numbers, E2 to remember these functions are called by the function name. So quartile, and then these parentheses we call them as arguments. So within the arguments you are telling this function that where to apply this function. Okay, so the range of the numbers which you are giving here is E2 to E13 in technical terms as the argument. So here this function arguments. First one is you will give the range of those numbers. In number 2 you will tell us quartile you actually want. So first one, so if you want first one, you will put it like this, 1, and you can drag it to here, and you can drag it to here. So since these were so he's taking the average, so that's why you get some fractions here. We can apply the same function here and introduce another thing to use. So we want to apply it downwards. What happens over here is actually I wanted to reuse the same function, and so that I can save my time for writing this function. Here in this formula bar you will see the function, and here in the cell you will this function will be applied, and you will see a value here. So what we do here is we see that the range of these numbers when you move one row downwards. You can fix that cell in which you need this function. We can go back to it, we can remove that and come back here, and we put it, and when we put a dollar sign, let's ignore this, I believe fixed. And once you change the since when you move downwards, moving one down to the So here it changes to, no, this will not work. Let me go. I think I put a dollar sign here. So it's fine. So here the range does not change. Here it was E2 to E13, and in order to see where it applies, so this blue matches to this blue thing, so this applies here, and when we move to the next cell, again let me click it here. So again the range stays the same. So the range is fixed by putting a dollar. So if you put a dollar sign before this, you can fix a column, and if you put $1 before this letter E on this side and then on this side between this number 2, then you can fix both the row and the column. We will do that in a moment. So here we are reusing the same function. All what we need is we just need to go and change the quartile here, the second argument. So second is, if you do second quartile, that is the median, so that we already got that. So we want the third quartile, so this is 3 here. So what does this mean? This quartile 1 is lower 25% of the values are up to this number 4.75, and third quartile is the 75th percentile, or 3/4, the upper 3/4. So the 75% of the values are up to 41, right? And if you want to take the maximum number, so that was 44 and that was 62 here. So if you take 62, everybody is inclusive. So up till the quartile 3 goes to 41. So 41 and below, all those numbers are, the actual number may not be there in this data set because it takes the those, since the numbers are even, so it will go and take the middle two numbers and take their average, right? And that will give you the median, and then it will take the lower half and split it again into 2, right? So then it will take the middle two numbers of the lower half, so that will give you the and take their average, so it will give you quartile 1, and then the middle two numbers of the upper half and take their average, so that will give you the quartile 3. So here it is 41. Now you can apply same here towards right. Since we did not fix the column, so it will be applied to our next data set, and we can apply it further on this one. Same way we can get the variance. The function is variance var.p if it's a population. Here we are dealing with a sample, so we can apply this var.s, and then we give our numbers E2 to E13, and then we can move on for the next data sets. Standard deviation function is, I will elaborate how this variance and standard deviation is actually calculated. So standard deviation again for these numbers E2 to E13, we can copy this range of numbers and just paste it, but now we are end of it. Standard error, let's see whether the function exists or not. No, standard error does not exist, so standard error is given by E2. So there is no function like this standard error, so we know that standard error is standard deviation divided by square root of n, and a sample size here it is 12, so what we can do is square root of 12. So we are applying a function down there which is square root, right? So that is our standard error for this all these treatments. How we calculate this standard deviation, and what is standard deviation? So we want to see at the average how values they deviate from the mean, right? So in this, for example, we just focus on this data set, this C, and we do it manually. So first we need to get these deviations.